Okay, we're going to continue with the normal distribution today. We're going to do a couple more problems. I'm going to show you some stuff in the calculator. So make sure you have your formula sheet and your calculator handy, because I'm going to show you kind of things in both today. So first example, we're just going to go through and do one big example, kind of reiterating what we did yesterday and kind of going backwards. So instead of finding like the probability of something, we're going to find like what numbers you would need. So suppose the mean height of an 18-year-old woman is approximately normal with a mean of 64 inches, standard deviation of 3. How tall are the tallest 3% of 18-year-old women? So if you think about our normal distribution, we're looking at the top 3%. So we talked about yesterday finding that Z star. What you have to do, so first step I need to find Z star. So I want to get as close to, now I'm not going to look up 0.03 because I want the top 3%. I want to look up 0.97. So I need to get as close to 0.97 as I can. So I know it's going to be positive. So 0.97. 0.9706, 0.9699. So we're going to go with negative or positive 1.88. I'm going to go positive 1.88. So that means my Z star is 1.88. Oops. Sorry, got it fuzzy. So now what we're going to do, we're going to work backwards. We're going to use the Z-score. Remember, that's x minus the mean over the standard deviation. And we're going to solve for x. So 1.88 would equal x minus 64 divided by 3. Now, let's hope you can all do your algebra. I know it's been a minute. But I'm going to do 1.88 times 3 plus 64. So x will equal 69.64 inches. But again, we're looking at the top 3%, so it's not a singular number. We're going to say x should be greater than or equal to 69.64 inches. Okay, because remember, a lot of the stuff we're not looking at a single value. We're looking at how tall are the tallest 3%? They're 69 inches or more. How short are the shortest 10%? So again, we're looking, that was bad, curve, but whatever. We're looking at the lowest 10%, so we got to find the Z star. So I'm going to look in my table. I want to get as close to 0.1 as I can. And I get negative 1.28. So you're going to do negative 1.28 equals x minus 64 divided by 3. Then when you solve, you get x equals 60.16 inches. But again, my answer is not a single variable. It's like they should be, x should be less than or equal to 60.16 inches. So the shortest 10% are less than 60 inches, so less than 5 feet. So my final answer has an inequality in it. What heights separate the middle 95% from the other 5%? And you don't have to draw a picture every time. I'm just a visual learner. So we have 95%, 0.025 on either side. So if I look up 0.025 or 0.975, I get a Z star of, I'm just not showing you how I'm looking it up. You can look it up on your own. Negative 1.96 and positive 1.96. So I'm going to make each one of these equal to my Z-score and simplify. So I'm going to do negative 1.96 equals x minus 64 divided by 3. And what positive 1.96 equals x minus 64 divided by 3. So then when you solve, in this case x is 58.12. In this case x is 69.88. You can write it two ways. Kind of depends on however you want to write it. You can say it's between 58.12 inches and 69.88 inches. Or you can write it mathematically. 58.12 inches, less than or equal to x, less than or equal to 69.88 inches. Either way, I'll give you full credit. What's the interquartile range? Okay, so now we're gonna go back to chapter 4. So remember the IQR is Q3 minus Q1. So Q3 is the 75th percentile, Q1 is the 25th percentile. So I'm going to look up 0.75, 0.25, find which Z star goes with them. It ends up being the same number, positive and negative. Now, when you get to 0.75, 0.25, 0.75 is like halfway in between 0.7486 and 0.7517. So I'm going to split the difference. So we're going to make this negative or positive 0.675, and this is going to be negative 675. Because it's almost halfway in between those two z-scores. So, same process. Negative 0.675 equals x minus 64 divided by 3. And positive 675 so here I get x is 61.975. Here I get x is 66.025. But it's asking for the IQR. So instead of just writing these out, I'm going to subtract. So 66.025 minus 61.975. So 4.05. So there's a 50% spread of 4 inches, which I guess makes sense if you think about height. Which heights would be considered outliers? So again, a throwback. Remember our rules should be less than Q1 minus 1.5 times the IQR, and anything greater than Q3 plus 1.5 times the IQR. So we already know the z-scores, or we already know Q1, Q3. This is Q1, Q3, Q1, Q3, because we subtracted them. So it's 61.975 minus 1.5 times 4.05 and 66.025 plus 1.5 times 4.05. So anything less than 55.9 inches, anybody more than 72.1 inches. So 55.9 inches or less, and 72.1 inches or more. Those would be considered outliers. Okay? So kind of going back to our chapter 4 stuff in terms of a box plot. Now, on the next page, on the back, this is where the calculator is going to come in handy. So you can do the normal distribution in the calculator. I don't do it a ton, especially on like the FRQ, but a lot of times like your chapter 7 test will be very long, so a lot of times on the multiple choice it might be easier to use the calculator. You'll see in the distribution menu where we've been doing binomial, the top two are normal PDF, normal CDF. Normal PDF gives you the probability density function for normal distribution with the mean and the standard deviation. It does give you the height at a particular value of x. Again, here's the calc behind it. For our purposes, never use PDF. Okay, just never use it. For us, the probability at a specific point when it's normal is nothing. It's 0. We're going to use the second one. So we're going to use normal CDF. So you're going to have a lower boundary point, an upper boundary point, a mean, and a standard deviation. So if you have a normal distribution, let's say of 100, standard deviation of 15. What's the probability I get between a 90 and a 105? So I'm going to go to normal CDF. I personally love using normal CDF when it's an in-between like this, because I hate having to find two z-scores, subtracting them, looking them up, subtracting them. I hate doing that. I find it really annoying and long. So this way, I just put it in the calculator. So normal CDF, my lower boundary would be 90. My upper boundary would be 105. at a mean of 100, standard deviation of 15. So there's my probability. So 0.3781. Now the trick with normal CDF is you must label. Just like binomial, if you don't label, every time you will get marked down 1 point. On the AP exam, they will take you from, if you have it like all correct, they will take you down to half credit. So it's real easy. What you're going to do, I like to put LB for lower bound, UB for upper bound, the mean, standard deviation. So make sure you label every single time. Now, if you're going to do less than or greater than, it's fine. You can do it the same way, but your boundary, so I'm going to do, let's pretend I want the probability x is greater than 102. So normal CDF would be my lower bound. My upper bound, I'm just going to put a bunch of 9s. The mean is 100, standard deviation is 15. And actually, when you're writing it out, I looked it up in the answer keys. You can write infinity. And here we're going to write negative infinity. It's just easier to write. But obviously there's no infinity button in the calculator, so that's why you have to put a bunch of 9s. So, normal CDF. So now the nice thing about normal CDF when you're doing a greater than, you don't have to do 1 minus. You just change your boundary points. You make the number be the lower boundary point and the infinity be the upper boundary point. So you don't have to do 1 minus when it comes to greater than. Another way to use the calculator to help you is if you want to check your answers. Because you should end up with the same answers. It may be a couple decimals off because the calculator is more accurate than the table. But what I would do when I was in your position is I would do the answer everything by hand because my teacher made me. But then I would go through in the calculator and double check my answers. And then again, what if it's a less than? Your lower bound is negative infinity. Your upper bound's 102, mean, standard deviation. Now, if you have an older calculator, again, the prompts won't pop up. You just have to type it in the way it's written on the paper. And this should be 0.5530 because they're complements. If you do not enter values for mu and sigma, it'll assume you're using the standard normal curve. Again, that's really only if you have an 83. It'll give you 0 and 1. The other way you can use the calculator is by using invert norm. So invert norm gives the value of a random variable x that has the given area to the left. So everything we did on this page, I can use invert norm for. So you have the normal distribution, mean of 100, standard deviation of 15. The value of x that corresponds to the 30th percentile. So again, we're going to have to make sure we label. So invert norm, 0.3, this would be the area to the left. And then this is your mean, and this is your standard deviation. So invert norm in the calculator, in the distribution menu, is the third one down. So 30th percentile, 100, 15. So what this will do, it'll look up the z-score and convert it without having to do all that work. So 0.9213. So instead of having to do looking it up like we did here, where's the third? Oh, it's not on this one. Looking it up like we did here and then converting it, you can just use invert norm. Separating the middle 95%, you can just do invert norm twice. So we have the area to the left, the mean, standard deviation, area to the left, the mean, and the standard deviation. So again, you can just do it twice. So you end up from 70.6 to 129.4. Okay, just make sure you put units when you have this stuff. Now, so using the calculator is definitely not needed. Like if you don't have a calculator, if you have an 83, if you don't want to use this, you do not have to. Like I said, it just saves time, especially in the multiple choice when I'm not grading your work. But on the FRQ section, when we are grading your work, it's much nicer to have it all written out. But it's just very handy if you need it.